Hello, physics students. This is Dr. Brenzy here. As we're getting ready for the Unit 4 summative tomorrow, I wanted to go over a couple of hard problems, but since we lost some time to the fake fire drill, or not fire drill, but the lockdown drill, I have to give this information to you over video. Now, if you have a lot of work to do on medium level problems, what I would suggest that you do is actually work on those instead of looking at this video. But if you have done all of those and you feel very confident about those, and well, I'll give you information on a couple of these hard problems and see if it's something that will help you on tomorrow's summative. So, two problems I want to look at is the first one. Let's look at advanced the 4.1.1 assignment and problem 2A. So in problem 2, we have a stunt woman who's falling off a 12-meter building onto a pad, and that pad stops her momentum. And we are being asked in problem A to figure out what is the impulse that she experiences while she is on the pad. So, I'm going to start thinking about what I know about impulse. So if I look through my notes, I know a couple things. First of all, I know that impulse is force times change in time, because it's a force applied over a certain amount of time. Well, I'm not given any information about force, and I'm not given any information about time, so that doesn't seem to be too promising. And then I remember, well, there's the impulse momentum theorem, which states that the impulse that something experiences changes their momentum. So, impulse equals change in momentum. Well, I know that the pad is going to bring her to a stop, so I know what her final momentum is going to be. It's going to be 0. I just have to figure out what her initial momentum is. Okay. So I know final momentum is going to be 0. Initial momentum is going to be her mass times what velocity she had just before she hit the pad here. Well, the problem is that I don't know that. But I'm given information about a height that she fell down from, and I remember from Unit 1 that we figured out what velocity is at a certain point when somebody falls off of a building. And that means we have to go back to Unit 1 and use our displacement and velocity formula. So, let's write down our displacement formula, and let's write down our velocity formula, and then we're going to write down our givens. So I know that she's going to fall down to a height of 0, which is ground level. She's falling from a height of 12 meters, excuse me. Don't know what velocity she's going to end up at when just before she hits the pad, but I know she's starting from rest at the very top of the building. Her acceleration, since she's in free fall, is negative 9.8 meters per square second. And I also don't know the time that it took her to fall that height. Well, I want to know velocity. So it seems to me that the equation I want to try first is the velocity equation. So I'm going to write that down, and I'm going to plug in what I know. I know her initial velocity is 0. That's given. But I end up being stuck because I don't know how much time it took her to fall 12 meters. Well, I do know something. I do know that this equation has time in it, and it also has distance in it. So let's see if that equation is going to be helpful. So let's write d equals di plus vit plus 1/2 at squared. And then what I do is I subtract 12 from both sides, because I notice that once I fill in my variables, I am just left with 12 minus 4.9t squared. So I get 12 on the other side of the equation. So I get 12 equals negative 4.9t squared. Then I'm going to divide both sides by negative 4.9. And when I do that, I get 2.45 equals t squared, and t equals 1.56 seconds. So it takes her about 1.56 seconds to fall 12 meters down to the pad. So now I can use that to plug into this equation. So I found that the velocity she'll have when she falls on the pad is 15.3 meters per second. So I can take that velocity, plug it into the change of momentum equation, and I found out her change of momentum is 1,300 kilogram meters per second, which means that the impulse she experiences is 1,300 Newton seconds. Now, just as an aside note, these are two completely different units, right? This is a unit of momentum. This is a unit of force times time. Well, if you were to actually break down newtons into their fundamental units, kilograms meters per second squared, and then multiply that by seconds, you would get kilogram meters per second. So the two units are equivalent. It's just that one is for impulse, F times delta t. The other is for change in momentum, delta p. Okay, so that's how you would do problem 2A in the 4.1.1 independent practice. Let me show you another one, and this one even gets more complicated. So again, I'll warn you, if you have other problems to work on, I would say go ahead and work on those other problems. Now, I put this on here knowing that it was a super challenging problem, and I knew that a lot of you would struggle with this one. And as I went through it, there are a lot of steps involved in this one. As a matter of fact, we're going to find out it takes 2 slides. But here we go. So the situation is that we have a car A, apparently driven by a drunk driver, and it plows into another car that's parked. So before our collision, we have this car, car A, traveling at some velocity, and it's going to hit car B, which is stationary and has its parking brake on. So that's what happens before. Then after the collision, it says the two stick together, and they're going to be traveling some velocity initially. But the problem says that something happens after that collision. What happens afterward is that it skids to a stop after a distance of 25 meters. Okay. Now, before I actually draw that, what I forgot to tell you is that I noticed that I have 2 velocities that I do not know here. So I'm going to call this one VB. So I'm going to put a B in there. And then this one's going to be VA. So one's going to mean before, and one's going to be after the collision. Okay. Now, again, like I said just a moment ago, these 2 cars slide or skid 25 meters to a stop. Okay, and we have some friction involved because it gives us a coefficient of kinetic friction. Okay, so that's what I know. What I ultimately want to find out in this problem is this V sub B. So let's set up my collision. So let's do a before and an after. And momentum is conserved in this collision. There are no external forces during the collision, or no net external forces. So I can say momentum's conserved. So let's figure out P total before and P total after, and set those equal to one another, and I get this equation. Unfortunately, it involves 2 variables. It involves this one I want to find, and it involves the velocity of the 2 cars after the collision. So, unless I bring some other information in, I'm stuck. Now, if I think about this carefully, this kind of looks like a force problem to me, because we're dealing with the force of friction, because friction is what's causing this car to come to a complete stop. It's also going to involve acceleration, and it also gives me distance. So I get the feeling that I'm going to need the distance equation and the velocity equation. Because after all, I want to find this velocity, so I can find that one. So let's write down the displacement and velocity equations again. And write down my givens. me back that up just a little bit. Okay. So these are my two equations, displacement, velocity. I know that it's going to skid a total of 25 meters. I know that it started at an initial displacement of 0. It's going to end at rest, so my final velocity is going to be 0. My initial velocity is going to be this v sub a. I don't know the acceleration this time, unlike the previous problem. So I have to leave that as a question mark, and I don't know how long it took for it to skid to a stop. So I actually have more unknowns than I want. I don't think I have any more information right now about time, but acceleration, by the way, what I'm doing down here, sorry to forget about this, I just actually plugging what I know into the velocity equation, and so I get a velocity a, or v sub a plus at equals 0. And notice I don't know these two things, so I better figure those out. I'm going to start with acceleration because I know that F net equals ma from Newton's second law, and I know that the force, the net force that's stopping this thing, is a force due to friction. So I'm going to set negative F sub F because friction is acting in the direction opposite the motion. And since we're traveling to the right, my friction force is going to be pointing to the left. That's equal to m times a. But I also know that friction force is equal to the coefficient of kinetic friction times the normal force. I know the coefficient of kinetic friction is 0.77 because they gave it to me. And I know that when you're on a horizontal surface, the normal force balances the gravitational force, mg, so I can replace F sub n with mg. So now I have negative 0.77 mg equals mass times acceleration. And if I start plugging in numbers here, I get this equation right here. But then I also noticed that I have a factor of 2,900 here, another factor of 2,900 here. So if I had to go divide those two out, that those two would divide out and they would cancel each other. So I'm just left with negative 0.77 times 9.8, which is negative 7.55.